do one simple thing. Listen carefully to every single word. I guarantee 80 to 90% of this topic will be ready in your mind right now. Physics is actually very easy.
Gravitational field strength. This topic contains 2 long questions, 4 to 5 short questions, and some MCQs. You will be able to understand all of these by paying attention to every word that comes out of my mouth. So, close your notebook, put your pen and notebook aside, and pay attention. Let's begin. First, I'll explain gravitational field only. First, I will explain gravitational field only from here to here. After that, gravitational field strength. Now, what is gravitational field? I try to explain gravitational field with the help of this magnet. I'm repeating. I try to explain gravitational field with the help of this magnet. Here we have a magnet and a piece of iron. If I place this piece of iron here, no magnetic force acts. If I move it a little bit closer, still no force, still no force, more closer, no force, no force here. Here force started to act. Here no force, but here force started to act. On the other side, same, no force, a little bit closer, no force, more closer, no force, no force. Here force started to act, means magnetic field is present here. On this side, same, no force, but here force started to act. And on this side, still no force, and here force started to act. Now what does it mean? It means that in this region, it means that in this region, this circular or spherical region, the magnetic field is present. Magnetic field is present in this region, and beyond this, magnetic field is not present. In this region, magnetic field is present. So, what does it mean? It means the area around a magnet where magnetic force acts is known as magnetic field. What is magnetic field? Magnetic field is the area around a magnet where its magnetic force acts. Here magnetic force acts, but here no magnetic force acts. Area in which magnetic force acts is known as magnetic field. And magnetic field lines are represented by lines. Magnetic field is represented by lines. These line shows magnetic field line, magnetic field. Closer line, stronger field, further apart, weaker field. Now, magnetic field is represented by lines. This is the center. These lines represents magnetic field. These lines are imaginary lines. They are not in real. We considered around this magnet there is a magnetic field. Magnetic field is the area around a magnet where magnetic force acts is known as magnetic field. In the same way, the area around the earth where its gravitational field acts is known as gravitational field. The area around earth, massive object means earth. Massive means having greater mass. The earth has greater mass. So massive object means earth. The area around earth where its gravitational force acts is known as gravitational field. Same here, area around a magnet where magnetic force acts is known as magnetic field. Same area around a earth, massive object means earth, where its gravitational force acts is known as gravitational field. This center part represents earth. Let's consider this center part represents earth, and these lines are the gravitational field lines. So gravitational field is shown by field lines. Gravitational field is shown by field lines. Closer line, stronger field. Here the lines are closer. The field is stronger here. Here lines are further apart. Weaker field. Let me explain this. Here lines are closer. In the same way for magnet, here stronger field, closer. Here lines are further apart and object is also further apart. So closer line, stronger field, further apart lines represents weaker field. Now gravitational, this is the gravitational field. It's a short question also. If a short question comes, define gravitational field, you can write to the answer to this question from here to here. Now what is gravitational field strength? Now we will discuss gravitational field strength. Gravitational field strength. Strength means power, force. Force of earth on unit mass. Earth pulls everything towards itself. The force of earth on this duster, the earth attracts this duster downward towards itself. So the force of earth on unit mass of this duster is known as gravitational field strength. Gravitational field strength. Force on unit mass. Force on unit mass is called gravitational field strength. Force of earth on unit mass of this duster, force downward, is known as gravitational field strength. Gravitational force on unit mass is called force of earth on unit mass of this duster is gravitational field strength. It is a vector quantity. Vector means it has direction, and direction is towards the center. Direction is towards the center of the earth. Massive body means earth. Massive, well, greater mass. Massive body, earth has greater mass, so massive body means earth, Jupiter, Greek, sun, etc. Now look here. Force on unit mass. Force on unit mass. Unit mass is gravitational field strength. This is gravitational field strength. Now how it is equal to A, acceleration? Look here. According to Newton's second law, F is equal to ma. M is multiplying here. When we move it to the other side, it will become divided. When we move m to the other side, it will be divided. Now F over m is equal to A. F over m is equal to A. Now this is general equation. Now specific for gravitational field, for gravitational force, we write G in the subscript with force and with acceleration also. AG represents the gravitational acceleration. Now we know that the gravitational acceleration is represented by G. So F over M, G is equal to AG. So force on unit mass means gravitational field strength is equal to AG. AG is the gravitational acceleration, or we represent gravitational acceleration with G. So now pay attention here. It's the key point you need to understand. It's a main point. So pay attention. It's another short question also. It's an MCQs also. So pay attention. It's a very important point. Now look at force on unit mass. Force on unit mass is gravitational field strength. So force on unit mass is, this is the gravitational field strength. This is the gravitational field strength, and this is gravitational acceleration. This is the gravitational field strength, and this is the gravitational acceleration. Both are equal. Look here. So gravitational field strength, this is gravitational field strength, and gravitational acceleration, this is gravitational acceleration, are equivalent. Both are equal or equivalent. This can be a short question like that. Uh, Explain the relation between gravitational field strength and gravitational acceleration, and the relation is equality. They are equal. And MCQs make gravitational field strength is equal to multiple choice question. First choice, second, third, and one choice will be gravitational acceleration. You have to mark gravitational acceleration. Now hope you got the point. This is the main conclusion on this. Now come here. Value of G. G is gravitational field strength or gravitational acceleration. G is the gravitational field strength, G. The value of G on the surface of the earth. This is the earth. This circle, this red circle represents earth. ME is the mass of earth. M mass, E earth, mass of earth. R is the RE is the radius of the earth. R radius, E earth. So this is the earth. Now when object is at the surface, the value of G on the surface of the earth, when object is at the surface, sorry, when object is on the surface of the earth, and the mass of object is, for example, m0. M0 is the mass of object. Now we have to drive the value of drive the equation for the object on the surface of the earth. Let us consider m0, mass of object, me, mass of the earth, re, mass radius of the earth. Right here, me, mass of the earth, and re, radius of the earth. Then according to the law of gravitation, we already covered this law in the last lecture, and this is its mathematical form. If anyone is unable to understand this, or anyone missed that lecture, go through it first. I'll put the link in the description. So this is the law of gravitation. F is equal to mm over r square, gmm over r square. Now gmm, first mass, second mass, me m naught, g me m naught over r square. R is the distance. So r is the distance from the center of the earth to the center of the object here. R is the distance. Now according to Newton's second law, F is equal to ma or mg. Now look here, as we know that According to Newton's second law, F is equal to ma. In case of gravitational acceleration, we write the gravitational acceleration is g, so F is equal to mg. It's also a weight, so the mass is m naught g. F is equal to m naught g. We call this equation as 1 and this as second equation or equation 2. Now, by comparing equation 1 and 2, by comparing equation 1 this and equation 2 this. Now look here. The left side of this equation 1 is F, and the left side of this equation 2 is also F. Both are equal, both are F, both are equal. So their right side will also be equal. If the left side are equal, then their right side will also be equal. Means this F is equal to this F, then this mg is equal to this gm over r square. Mg equal to this gmm over r square, gm over r square, by comparing. Now we have to find the value of g, so we need to move m to the other side. M is multiplying here, it will become divided to the other side. So g as it is equal to, as it is, gm e m naught divided by r square, and this m to the other side will come in the denominator. Now m naught same, they will cancel out with each other, and gme our r square is left here. This is our final equation. This is the value of g on the surface of the earth. Now for general form, what does mean by general? This me, mass of earth, this equation is specific for the earth, and for general equation for other planets, Miriam, Jupiter, etc. So for other planets, this is general equation. For other planets, this gm over r square, me is replaced with m. It's a general mass. This m can be a mass of Jupiter, Miriam, Sun, etc. As r can be the radius of that planets. So general formula for any planet is this. This is the formula for the earth. This is general formula for any planet. Both are same. gm over r square, both are same. But this is general and this is for specific earth. Now as we know that the mass of the earth, me, the mass of earth is 6 multiplied 10 power 24 kg. And we also know that the radius of the earth is, the radius of earth is 6.4 multiplied 10 power 6 meter. And the value of g is also known, 6.67. It's a universal constant value, 6.67 multiplied 10 power minus 11 Newton meter square per kg square. All of these values are known. If we plug in these values to this equation, if we put these values to this equation, the value of g 6.67 multiplied 10 power minus 11, 6.67 multiplied 10 power minus 11, the value of g we plug in here. And then the mass of earth is 6 multiplied 10 power 4, 6 multiplied 10 power 4, we plug in here. Then in denominator, radius is 6.4 multiplied 10 power 6, 6.4 multiplied 10 power 6 square as it is. Now by using calculator, we can, by multiplying and dividing, we will get 9.8 meter per second square, the value of g on the surface of the earth. Now here, Another short question or MCQs. Pay attention, it's important. It's a key point. Another. A short question may come as, on what factor G depends? G depends on the mass of the earth and the radius of the earth. G depends on only on the ME, means mass of the earth and radius of the earth. But G doesn't depend on the mass of object. In final equation, there is no mass of the object. The mass of object is m naught, which already cancelled out. So in final result, there is no mass of the object. So G doesn't depend on the mass of the object. G doesn't depend on the mass of falling object or the mass of object. Light or heavy will fall at the same rate. So G m naught is the mass of object which already cancelled out. In final result, there is no m naught. So G depends only mass of the earth and the mass radius of the earth, and G doesn't depend on the mass of the object. This is another short question and maybe may come as an MCQs. Now, the variation of G with altitude or with height. Now look here at, first we find the value of G at the surface of the earth. Here. Now we will find the value of G at some height. Look here. Variation of G with altitude. Altitude means height. Sorry. Value of G at some height. So first we find the value at here. Now value of G at some height, at height h. No object is placed here at some height from the surface of the earth. Now then let us consider h is the height from the earth's surface, and gh means the value of G at some height from the earth, the value of gravitational acceleration at height h. Now this equation is for an object on the surface of the earth where the distance is RE, equal to the radius of the earth. When the object was on the surface of the earth, then the distance was RE. Now the object is at some height and the distance will be R plus h. From here to here R and from here to here h. So the total distance becomes R plus h. So for this we replace R with R plus h in this equation. The remaining will remain same. Only R will be replaced with R plus h. R plus h square GME as it is. This is our. Let me repeat this. This equation is when the object was on the surface of the earth and the distance was RE. When object is at some height, then the distance becomes R plus h. So we have to replace R with R plus h. So we replaced R with R plus h. The remaining equation is same as it is. Now by rearranging this equation, R square is dividing. When we move it to the other side, it will be multiplied. Then GME is equal to GR square. GME is equal to GR square. Now plug in the value of this GME here. G over H. GME is equal to GR square. So plug in the value of GME here. GRE square. The denominator is same. R plus H whole square. Now pay attention again. G is constant 9.8. The radius of Earth is also constant, only the h is variable, and h has inverse relation with g. This equation shows that as h increases, g decreases. H means altitude. So this equation shows that as altitude increases, g decreases. This is the final result.